How will artificial intelligence affect scientific research? Especially, how will it affect research in physics? And what are the implications in technology, which is based on physics and principles of physics? That is something I just want to briefly discuss here. One of the key aspects of doing physics is that it has three broad kind of divisions. They are interrelated. One is, of course, theoretical physics. The other one is experimental physics. And the third one is usually called as the computational physics. Now, these three kind of subdivisions are not very strict. They have overlapping interests, and also they go together to make physics a more coherent way of understanding uh, matter, and also to understand the universe in a broader sense. Now, the question is, how does AI come into picture in this particular kind of tripartite agreement between the parts which I just mentioned? One of the aspects which is already very obvious is the computational physics is already been kind of rejuvenated by emerging technologies in high performance computing. Many of my own colleagues actually utilize supercomputers to do very complex calculations, which not only address questions all the way from complex cosmological problems, dark matter, and all the way up to biophysics and understanding molecular biophysics, what happens inside a cell, and in between everything which is happening right from fluid dynamics to optical physics to condensed matter physics, how electrons behave in various solids. And semiconductor technology has also given a boost to this kind of questions and various different avenues. So, in that sense, computational physics has already been kind of impacted by how this particular tripartite nature is taken care of. The AI really plays a critical role in all these things because AI brings in a boost in the process of computing various different differential equations, integral equations, and various forms of calculations, which might have taken a very long period of time for one to actually look into it. The other aspect is that because of the machine learning and also a variety of ways in which coding can actually be boosted and assisted, artificial intelligence already has played a very critical role in kind of making coding very accessible, which means that one can now look at the physics problems, set up the problem, and ask any particular source of artificial intelligence based technologies to really give the foundational code which is required for you to run that particular physics problem. Of course, it requires some kind of an exposure to the technology which is already available, but it is something which has really boosted the way people have been able to utilize sources, especially computational sources, thanks to the artificial intelligence technology. Coming to the theoretical physics, now there are many avenues for people to really look at this particular problem of various different interactions in physics, all the way taking from string theory down to the biophysics. There are various different ways in which you can do complex mathematical analysis using artificial intelligence based methods. I'm not going to go into the specific large language models, but there are many, as you probably would be already aware of, in how to utilize these models and probably do a complex calculations, which might otherwise not be possible for conventional techniques, or it would have taken a very long duration for one to perform such kind of calculations. In that way, it has really, you know, changed the game for various different researchers. Of course, it always comes with a caveat that such kind of research uh, should be tested for accuracy, and it should be tested for how it is actually been functional, how useful it is compared to other methods. And there are opportunities sometimes where you don't need to worry too much about, let's say, using very complex calculations, but you can figure out things through very smart methods, what a lot of theoreticians have already come up in the past. So there is scope for that kind of approach also. Nevertheless, it already has given ma- a variety of platforms for people who do theoretical physics to utilize artificial intelligence to really up their game. Now, the third part, which is the interface of artificial intelligence with experimental physics. That is something which is very fascinating and which might be also interesting to a lot of engineers and also entrepreneurs, because that is one particular place where I think there is still a lot of scope for exploration, because a lot of buzz which has happened in last 2 to 5 years or so in the LLM based technology has always been in the domain of either in the form of text or in recent times in form of videos and audio and etc. And it essentially utilizes some complex AI algorithm which is based on some very foundational mathematics which already has been figured out, and a very interesting computer science. But when it comes to the interface of the artificial intelligence technology with the hardware, robotics is one of the great platforms to really explore. But one should ask, to what extent will the robotics be able to implement things which can be applicable to a particular situation and also to a particular ecosystem. Say, for example, any kind of robot which is designed in the US, in the Japan, or in China might not find a large amount of applications within an Indian scenario. For example, can it work on Indian roads vis-a-vis, let's say, compared to, let's say, some particular European or Japanese or Chinese kind of transportation system? That is where the adaptation becomes very important. That is where the definition of the problem becomes important, and that is a great place for a lot of entrepreneurs to also pitch in and utilize the interface of the AI with the physical systems. Now, you may not be able to employ the techniques and technology which are available right away. That is where the experimental physics comes into picture. One will have to do a careful experiment to test out the interface of the AI with the physical systems. And that's where the prototypical applied physics laboratories and conventional laboratories become very critical. One of the first ways to approach this problem is to ask how you can modulate or modify the existing undergraduate experiments in a physics laboratory by using intelligence based techniques. That interface is still yet to be cracked. I haven't seen many platforms where undergraduate experiments have been kind of upped in its functioning thanks to the available AI technologies. There are few techniques and methods which have been developed in recent times, but it is a niche. It has not become a something which is widely spread. In fact, I think that's where probably one of the most important kind of expansion of AI has to take place, because at that particular interface, the physical principles and the physical laws will come in confrontation with the limitations of artificial intelligence technology. And that's probably one of the places where a lot of research and exploration is yet to be performed. My hope is that testing out these principles first at the classical limit, which is the everyday world which we live in, would be the foundational requirement, because that would be slightly easier compared to, let's say, systems which are micron scale, or if you go even beyond that into the quantum regime, where the interface of artificial intelligence and quantum mechanical systems become outstandingly interesting. In fact, that is probably much more into the future compared to what even a classical system is interfacing with the technologies which are available. So these three aspects which I have mentioned, first is the classical mechanics, uh, uh, which is mainly based on the principles which are everyday kind of systems. The other part is the statistical physics, where you have multi-particle systems where you can utilize the AI-based technology. People have been using that. For example, how to image a large crowd, and how do you actually channel a large traffic which is actually moving in a particular system, and such kind of questions are ripe for people to explore. And the third part, of course, is the quantum mechanical world, where the system is probabilistic in nature, and you no more can utilize the deterministic principles of measurement. And therefore, how do you interface AI with quantum systems is probably one of the greatest challenges to emerge in recent years. So there are many opportunities um, in that all the three pillars which I mentioned, in computational physics, in theoretical physics, and of course in experimental physics. So the future really is very interesting. So one will have to really ask questions of how physical laws can be interfaced, and physical kind of systems can be interfaced with artificial intelligence based platforms. There's a lot to learn, and there's a lot to explore in that particular direction. And these kind of questions are not just only of curiosity based kind of explorations. There's also a lot of interest to take it forward and make it into workable technologies. The engineering and the entrepreneurial kind of system, kind of viewpoints become very important in such kind of situation. And I'm hoping that there will be a lot more to think and speak about in the coming days. I'm very curious to know what people have to think about this. Do let me know in the comments. I'd be very interested to know what are the kind of questions people have been asking, and I'm hoping also to bring in some very interesting questions from the history and philosophy of science, which also plays a critical role to get new ideas into such kind of systems, especially those related to quantum mechanics and quantum optics, for example. There's also a course which I'm going to offer in next few weeks to our senior undergraduates and some PhD students, and I'm looking forward to really thinking about quantum mechanics and its interface with various different systems in both in terms of machine learning, in terms of artificial intelligence, and also classical quantum interface, which is another very fascinating principle. Yeah, so artificial intelligence, human intelligence, and physics intelligence all have to actually be brought into one particular platform. And I'd be very interested to know what you're thinking about in such kind of systems. And do let me know about your thoughts in the comment sections. And until next time, bye bye.